Imagine you tell an AI assistant, find me a blue jacket under $50, add it to my cart, and check out. Today, the AI has to take a screenshot of the website, send it to a vision model, squint at pixels, and guess where the buttons are. It's slow, expensive, and it breaks every time the website changes its design. Google and Microsoft just shipped a fix for this. It's called WebMCP, and it's about to change how AI interacts with every website on the internet. Let me show you exactly how it works. Let's start with the problem. Right now, when an AI agent needs to do something on a website, it has one option. Take a screenshot, send those pixels to a vision model, and try to understand what's on the screen. Let me show you what this looks like with a real example. Say you're building ShopSmart, a simple online store. A user asks their AI assistant to search for running shoes under $80. Here's what happens behind the scenes. Step 1, the agent opens ShopSmart in a browser. Step 2, it takes a screenshot of the page. That screenshot alone costs over 2,000 tokens to process. Step 3, it sends the image to a vision model and asks, where is the search bar? Step 4, the model guesses the coordinates. Step 5, the agent types in running shoes and takes another screenshot. Every single action requires a new screenshot, a new vision model call, and a new guess. Now imagine ShopSmart redesigns their homepage, new layout, new button positions. Every single AI integration breaks overnight. This is the reality today. AI agents interacting with websites through screenshots is like trying to read a book by taking photos of each page and running OCR. It works sort of, but it's fragile, slow, and incredibly wasteful. This is where WebMCP comes in. WebMCP stands for Web Model Context Protocol. It's a new browser API that lets websites directly tell AI agents what actions are available. Think of it like this. Right now, an AI visiting a website is like a tourist in a foreign country with no map and no language skills. They're looking around, guessing what things do, hoping they press the right button. WebMCP gives the AI a complete menu. Here are all the things you can do on this website. Here are the inputs each action needs, and here's how to call them. Instead of taking screenshots and guessing, the AI gets a structured list of tools: search products, add to cart, apply coupon, checkout. Each tool comes with a name, a description, and a clear definition of what inputs it expects. The website declares its capabilities. The browser exposes them through a new API called navigator.modelContext, and AI agents discover and use them. No screenshots, no pixel guessing, no breaking when the design changes. Let me walk you through exactly how WebMCP works under the hood using our ShopSmart example. There are two ways a website can expose tools to AI agents. The first way is declarative, using plain HTML. You know those HTML forms you already have on your website? With WebMCP, you just add two attributes: tool name and tool description. That's it. Your existing search form becomes a tool that AI agents can discover and use. No JavaScript required. The browser reads the form fields, their types, their validation rules, and automatically creates a structured tool definition. The second way is imperative, using JavaScript. You call navigator.modelContext.registerTool and pass an object with the tool's name, description, an input schema that defines what parameters the tool accepts, and an execute function that runs when the agent calls the tool. Here's the beautiful part. The execute function is just regular JavaScript. It can call your existing APIs, update the DOM, do anything your app already does. You're not building a separate system for AI. You're exposing what already exists. When an AI agent visits ShopSmart, the browser tells the agent, this page has 4 tools available: search products, add to cart, apply coupon, and checkout. The agent picks the right tool, sends the right inputs, and gets structured data back. No screenshots needed. Let me show you the difference with real numbers. Before WebMCP, searching for running shoes on ShopSmart with an AI agent looked like this. Take screenshot, 2000 tokens, vision model processes, image about 500 milliseconds, parse results, another 500 tokens. Click a product, take another screenshot, 2000 more tokens. read the price. Another vision call, add to cart, screenshot, guess button location, click. That's over 10,000 tokens in multiple seconds just to search and add one item. After WebMCP, the same task looks like this. Agent calls search products tool with query running shoes and max price 80, gets back structured. JSON with product names, prices, ratings, 20 tokens. Agent calls added to cart with the product ID, gets back confirmation, 20 more tokens. Total about 40 tokens, near instant response, and it works perfectly every single time. That's an 89% reduction in token cost. But it's not just about cost. The real win is reliability. When ShopSmart redesigns their website with a new layout and new styling, the screenshot approach breaks completely. The search bar moved, the buttons changed. But the WebMCP tools, they still work perfectly. The tool contract says, give me a query and a max price. That doesn't change just because the CSS changed. The tools survive redesigns. That's the real game changer. Let's look at actual code. I want to show you how ShopSmart would implement WebMCP. First, the declarative HTML approach. Take your existing search form. Add tool name equals search products and tool description equals search the product catalog by keyword and price range. That's literally it. The browser reads the input names, types, required attributes, even validation patterns, and creates the tool schema automatically. Now the JavaScript approach for more complex tools. You call navigator.modelcontext.register_tool, give it a name, add to cart, a description, add a product to the shopping cart, an input schema, product ID as a string required, quantity as a number with minimum 1, an annotations object with read-only hint set to false because this modifies state, and an async execute function that calls your existing cart API. The execute function receives the parameters and can optionally request user interaction. This is important. For sensitive actions like checkout, the agent can ask the user for confirmation before proceeding. The user sees the action in their browser, confirms it, and the agent continues. Human in the loop, built right into the protocol. The response comes back as structured content, an array of content objects, each with a type and text field. Clean, predictable, parsable. No scraping required. Now let's talk about what you can actually build with this. Use case 1, travel booking. Imagine Kayak or Booking.com exposing tools like search flights, filter by price, select seat, and book flight. You tell your AI assistant, book me the cheapest direct flight to Tokyo next Friday, window seat. The agent calls search flights, filters results, picks the best option, and books it. All through structured tools, no screenshot gymnastics. Use case 2, customer support. A support platform exposes tools like get ticket status, update priority, add comment, and escalate to human. An AI support agent handles routine queries instantly and escalates complex ones. The user sees every action in the shared web interface. Use case 3, enterprise dashboards. Think Salesforce, Jira, or any internal tool. Expose tools like generate report, filter by date range, export CSV. An AI assistant can navigate complex enterprise software that normally requires training to use. Use case 4, developer tools. Imagine GitHub exposing tools for creating issues, reviewing pull requests, merging branches. Your AI coding assistant doesn't just help you write code, it helps you manage your entire development workflow. The common thread is this: any website that people interact with can become AI accessible, not through brittle screen scraping, but through clean, structured, reliable tool definitions. If you've been following AI development, you've probably heard of MCP, Anthropic's Model Context Protocol. It lets AI connect to databases, file systems, APIs, and other backend services. So how does WebMCP relate to MCP? Think of it this way: Anthropic's MCP is for the backend. It connects AI to your servers, your databases, your internal systems. It uses JSON RPC communication and runs server-side. WebMCP is for the front end. It connects AI to live web pages that users are actually looking at. It uses the browser's native API and runs client-side. The key difference: shared UI context. With backend MCP, the AI works in the background. The user doesn't see what's happening. With WebMCP, the user and the AI share the same web page. The user sees every action, can confirm sensitive operations, and maintains control. They complement each other perfectly. Use MCP to connect your AI to backend systems. Use WebMCP to connect your AI to web applications. Together, they create a complete picture where AI agents can work with both your infrastructure and your user interfaces. So who built this? WebMCP is a collaboration between Google and Microsoft, published as a W3C community group standard. That means it's open, it's not controlled by any single company, and it's designed to be a web standard like HTML or CSS. Google is shipping support in Chrome version 146. Since Microsoft Edge is built on Chromium, Edge support will likely follow. The spec was published on February 12, 2026, and it's already available as a feature flag in Chrome Canary. The full specification is open source on GitHub under the W3C Web Machine Learning Group. It has an active community with dozens of open issues and ongoing discussions about security, privacy, and the right way to handle sensitive operations. This isn't a weekend experiment. This is two of the biggest tech companies in the world agreeing on a standard for how AI should interact with the web. That's significant. Here's how you can get started today. First, download Chrome Canary and enable the WebMCP feature flag in Chrome Flags. Second, visit the W3C specification on GitHub. I'll link it in the description. Read through the proposal document. It's surprisingly readable. Third, try adding WebMCP tools to a simple web app. Start with the declarative HTML approach. Just add tool name and tool description to your existing forms. Fourth, think about your own projects. What actions could you expose as tools of day? What would your website's AI menu look like? The agentic web is coming. Websites won't just serve pages to humans, they'll serve structured capabilities to AI agents, and WebMCP is the protocol that makes it possible. If this video helped you understand WebMCP, subscribe for more breakdowns of the tech that's shaping the future. See you in the next one.